Okay, just a quick summary of further functions. Extension 1. Alright, so we're going to start, I'm just going to do a curve like this, that's minus 1, 2, and we're going to make that go through minus 2. Okay, so the first thing that you need to... Okay, here we go, this is further functions, year 11. So, looking at the first one, the first thing that we have to do when we do the reciprocal ratio, 1 over f of x, is the first thing we need to do is that where the x-intercepts are, that's where the asymptotes are. Because the asymptotes are where y equals 0. So if you have y equals 0, if you flip 1 over 0, it will be undefined, and that's why that's where the asymptotes are. So the asymptotes are where the intercepts are. Okay, second point. Once you've done that, then everything else you just flip it. Okay, so if it's like a half, it'll go to 2. If it's like 2, it'll go to the half. So the small ones get big, and the big ones get small. So everything just flips, and it kind of like inverts, goes like that. Okay, the square root one. So with the square root, the f of x must be greater than or equal to 0. So you have to rub out. You have to rub out below the x-axis right from the start. Okay, second step. Once you've rubbed out, then what it does, it flattens the curve. A little bit like the coronavirus curve. So it goes like that. So everything gets flattened. If it's like a loop circle like that, it gets really flattened out because everything gets pulled down. When you have absolute value, so you have the absolute value on the outside, basically what you may do is you draw that, then you draw that. Okay, and to draw that part there, you reflect in the x-axis, and then the last step that you do is you rub out below the x-axis. So you rub out below the x-axis because basically the y equals an absolute value. So y is greater than or equal to 0 because the y equals an absolute value. Okay, so when we've got the absolute value there, that means that it is an even function. That means you cross out any curve on the left-hand side of the y-axis. Once you've crossed that out, then you just reflect it in the y-axis. Okay, the next step. All right, y squared. So y squared's pretty simple because basically what you have to do is you draw y equals root f of x, then you draw y equals minus root f of x. And the reason that you do that is because when you got y squared is f of x and you square root it, that would be plus or minus the square root of that. But there is a restriction because the restriction comes from the fact that when you do this, all right, the y equals root f of x, basically the restriction would have been initially when that was greater than or equal to 0. So the restriction comes from that initial part, and then you just when you're drawing the second part, y equals minus root f of x. So when you're drawing this part here, that is you just have to reflect it in the x-axis. And the whole reasoning behind that is because the y squared is plus or minus the square root of f of x. I'll just make that a little bit clearer. Plus or minus the square root of f of x. Okay, so I've got some curves here to quickly sketch. So looking at the first one, that one there, so first of all we draw y equals f of x. Then we draw y equals minus f of x, because what's inside could be plus or minus, and then we do the rubbing out thing. So we rub out, and that's what our curve looks like. Okay, this one here, we draw y equals f of x, then we rub out on this side, so that's 2, and then we reflect it. So it's going to be like that, and then it's going to be like that. You reflect it, you reflect in the y-axis. So it is an even function. Looking at number 3, so that's 2 minus 1. So when I do number 3, basically it's a square root, so you don't have anything underneath the axis, so that gets rubbed out. And then basically, at square root of 0, 0, you flatten the curve, flatten the curve. When you do y equals x squared, you've got the same function, you've got the root f of x, but then because y equals plus or minus the square root of root f of x, you draw the negative version, which means you just reflect it in the x. So you reflect that in the x-axis. Okay, and the next one, so I've got that's like that. That's 2, that's minus 1. Okay, now when you look at this, that means that f of x can't equal 0. So where the asymptotes, where your intercepts are, so your intercepts become your asymptotes, and then everything in there, basically, it all gets flipped. So it all gets inverted, so it's like that. So it becomes the yellow curve, and it all gets turned upside down. Okay, let's look at this one here. So initially we start like that. That's 4 minus 3. Then we draw the negative version, and then we rub out. So that's what your curve looks like. This one here, we draw the initial curve. Then we rub out this, because we don't do it, and then we reflect it in the other, like that. So actually go a bit further, because it'll go to minus 4. Okay, and then we've got the square root curve, so draw your initial curve. Initial curve's 4 and minus 3, and then because it is the square root, you rub out below, and then with the other part, you just flatten the curve, flatten the curve. So it actually looks like that. And then when you're doing this one, keep the same curve. That's 4, and then you just reflect that, like that. And doing this curve, so the initial curve looks like that, 4 minus 3, and then you, the asymptotes will be here, here, and here, and then because you invert everything like this, so everything gets inverted, so it's actually the green curve is your solution. And this one here, alright, so the absolute value one, you draw the initial one, 2. This is going to be hard in that small amount of space. I might just fix that up a bit. Just going to put it up here. Y equals the absolute value of f of x, like that. Okay, so we'll draw the initial curve. It goes through 4. That's minus 3, that's 0, and that there is 2. Okay, so what we're going to do now, we need to draw the negative version of that. That's minus 2. So once you've drawn the negative version, because the y value has to be positive, you need to rub out there, and that's basically what your curve will look like. Okay, so it's like basically down there, up there, down there, and there's your asymptote. Alright, we've got this one here, so we draw our initial curve. That's 2, and then what you do is you rub this part out, and then you just reflect this part in the other side, like that. So that's what your curve looks like. You reflect it in the y-axis. Okay, let's draw the initial curve for this one. That's 2, 4, there's the asymptote. Okay, so when you look at that, you have to rub out below, because you can't square root it. Then everything gets flattened. So the square root of 2, that asymptote now becomes root 2, and the 4 becomes a 2, and the whole curve just comes down lower. So if I was doing it so that you can see, that'll stay at minus 3. Still goes like that, but the thing is, that will be root 2. and that will be 2, because when you square root the 4 you get 2, and when you square root the asymptote, which is 2, you get root 2. Okay, alright, so once you've got that curve, like that, that's going to go 2, and the asymptote is root 2, then what we're going to do, minus root 2 minus 2, so going to look at that, I just reflect it. Okay, if I draw my initial curve for this one, everything gets flipped, including the asymptote, so that becomes 1 on 2. I might just sketch it here. So the asymptote becomes a half, but the 4, this 4 here, actually becomes a quarter. So I'm going to need a lot more room, so I might go back to my first one and just give myself a bit of room here. Might have actually do it on the proper curve. Okay, so if we do it on this curve, this 4 becomes a quarter, so that means your intercept is a quarter. This here is your asymptote, because that gets flipped and it's y equals 0. That there becomes a half, so your asymptote is at a half. So the curve's going to come in from this way, right? But then when it comes, it's going to come in like that, and then it's going to go up there. And this one here is just going to invert. So the actual curve is like that, and then it comes up here, and it hits it at a quarter. That hits it at a half, and intercept a quarter. Okay, so there's our summary of our rules again.